What if we need to store a number that's not a whole number like pi? If I try to put a number like pi into a variable with data type integer, I'm going to have problems. So if I declare an int like int pi equals 3.14, it's not going to work. That's where the float is used. The float data type has a huge range, but there's a catch which we'll talk about in 1 second. To declare a float, just type float, name your variable, and initialize it if you want. Another way to declare a float is to use the exponential notation. So if I put float another float equals 3.14 E3, that's the same thing as saying 3.14 times 10 to the third, which is 3,140. Floating point representation involves breaking up a number into a fractional part and an exponent part and storing the parts separately. And they occupy 4 bytes of space. However, we hinted earlier that the bigger the float is, the less precise it is. Next, we have the char. Char stands for character and takes 1 byte of storage. Normally, you'd use a char to hold a character such as a letter or a symbol. They range from negative 128 to positive 127. There are 2 ways to declare a char shown below. We can declare a char as a letter, like here, and if we declare a char as a letter, we need to enclose that letter or character in single quotes. Or we can declare it as a number, where we don't need the single quotes. Note that when you declare a char as a number, what's actually being stored is a letter or character whose ASCII value corresponds to that number. So in the second declaration here, the number 98 corresponds to a lowercase b in ASCII. And you can also use the signed and unsigned qualifiers with the char too. Next, we have the bytes. Bytes take up, you guessed it, 1 byte of space, and they have a range of 0 to 255. These can come in handy if you're really pressed for program space, and you know your value won't go out of this range. And this example shows you how to declare a byte. Finally, there's the Boolean data type. Boolean values take up 1 bit, not byte, but 1 bit of space, and can either be true or false. That's it. If you put a non-zero value into a Boolean variable, it'll be considered true. So for example, Boolean my Boolean equals 37 evaluates to true. False can be represented by a 0, the word low, or the word false. So if we do a declaration like my Boolean equals 0, low, or false, all 3 of those above statements mean the same thing and are considered false. Similarly, the true state can be represented by the word true or the word high, in addition to any non-zero number. This data type would come in handy if a variable only needs to represent 2 states. I know all the stuff we've talked about so far is a heck of a lot to remember. So I went ahead and included this nifty little chart which summarizes the data types we just went over.